8.4, applications of vectors. Sometimes it's necessary to find a vector that will counterbalance a resultant. This opposite vector is called the equilibrant. That should remind you of the word equilibrium. We're trying to find a balance. The equilibrant of vector u is the vector negative u. I might think of it as r for resultant. The equilibrant is going to be negative whatever the resultant is. Now, I don't really want to think about this as a negative number. That negative kind of indicates direction. I'm pulling back equal and opposite. So let's draw a picture. Let's say we have a force. Okay, let's say we have one force here, and we have another force here with some angle in between. Okay, two forces acting on us. This looks like the dog walker problem. We already know how to find the resultant using the parallelogram method. The resultant of those two forces is as shown. But if I want to find equilibrium, I need to counterbalance that. And so I'm going to pull back on those dogs with equal and opposite force. Now again, I don't like to think of that as a negative number. I like to think of that as the opposite direction. So let's do an example. Example 1, find the magnitude of the equilibrant of forces of 48 newtons and 60 newtons acting on point A if the angle between the forces is 50 degrees. Then find the angle between the equilibrant and the 48 newton force. Now the first part is something that's going to look familiar to you. The second part's maybe new. So let's start with the first part. You've got forces of 48 newtons and 60 newtons with 50 degrees in between. Okay? I want to find the equilibrants, but first I'm going to find the resultant. So let's find the resultant. Okay, there's my picture. Draw a picture of the resultant. And I want to point out to you, we understand that this is not going to be half and half, right? That's not going to be 25-25. Keep that in mind. Because this force is stronger, we would expect the resultant to be skewed a little bit more towards the stronger force. So maybe it's 26 and 24 or something like that. I don't know what it is, but it's definitely not 25 and 25. Okay? What we know about parallelograms is that consecutive angles are supplementary. So I would know that that's 130 degrees. That's kind of a big deal. Also, because of this parallelogram, I know this side is 60 newtons. And so what we want is a triangle, and that's what we've just formed. We've formed a triangle, but not only that, you think about the Temple Runner, and the Temple Runner sees a side, angle, side. If you see side, angle, side, you'll know case 3, you'll know law of cosines. So we can do law of cosines to find that side r by finding this partnership between side r and that angle 130. And let's set up our law of cosines. R squared equals 48 squared plus 60 squared minus 2 times 48 times 60 cosine 130 degrees. Mainly, it's a calculator exercise. Let's just make sure we're in degrees. Yes, we're in degrees. 9606. That wouldn't be your answer yet. That's still r squared, 9606.46 or so, but I'm going to square root that. With the square root of that number, 98.01. Let's call that 98 newtons. So what we've just found is the magnitude of the resultant force. We just found the resultant was 98 newtons. What the question asked me was the magnitude of the equilibrant. Okay, the magnitude of the equilibrant. And so that means that I'm going to need to pull back in the opposite direction. So you can call that 98 newtons in the opposite direction, or sometimes you can call that negative 98. Don't think about that as a negative number, though. Think about that as a direction. That means 98 newtons of force in the opposite direction. So that will be our equilibrant. As for the second part, and this is the harder part, I think, it's just a little bit harder to understand. Find the angle between the equilibrant and the 48 Newton force. So I think the key is to draw a good picture. Draw a good picture so that you can visualize what they're saying. Find the angle between the equilibrant and the 48 Newton force. That means right here. We want to know that angle. And so it looks like it's going to be easy. Those of you who think that this is 25 and 25, if that was 25 and 25, this would be easy because all we do is take 180 minus 25. That's 155, and that would be our answer. Okay? However, we don't know that that's 25 and 25. It's not. Okay? Remember, we said it was going to be shifted. The resultant was going to be shifted towards the 60, so it might be like 24 and 26 or something like that. I don't know. But I can figure out anything in this triangle that I want using law of sines and law of cosines. Okay? Law of sines and law of cosines are going to allow me to figure out this angle, perhaps. You don't have to use the letter alpha. You can use anything you want. I just wouldn't use the same symbol as what I used over here. So I used alpha. And I can use law of sines. Again, law of sines has to do with partnerships. This alpha would partner with this side 60, and I already have this partnership between the 98 newtons and the 130. So I can find that alpha, that angle alpha, using law of sines. Sine alpha over 60 equals sine 130 degrees over 98. And so we've done this. We're going to multiply both sides by 60. So it's going to look like 60 sine 130 divided by 98, 0.469. Sine alpha equals 0.469. And then do, what do we do to finish that one up? Inverse sine. Inverse sine on that, because it's law of sines, on that number. Give me, let's call that 28. Alpha is 28 degrees. Okay? 28 degrees right there. Remember when we thought it might be 25 and 25 or 26 and 24? Well, it looks like it must be 28 and 22. Okay? But what's important is this is 28. So if I want to find this, all I have to do is subtract from 180, right? Theta is going to equal 180 minus 28. What's that? Theta equals 152. 152 degrees. So notice what we've just found. We found the magnitude of the equilibrant was 98 newtons in the opposite direction of the resultant. And that theta, which was the angle in between the equilibrant and the 48 Newton force, was 152 degrees.